So moving next, we need to study a stress strain curve. We need to study stress strain curve. This is a graph plotted between stress and strain. This is obtained from experimental result. Probably this experiment is performed on material like steel. This graph is being obtained. I will explain how this graph is obtained, and we will deal about different aspect of this graph. Now, same experiment like this body. Okay, when I am applying the force on this body, when force is being increased means stress is being increased, then length also get increases. There is a linear relation between stress and strain. I will increase force, the length will get increased. Stress is proportional to strain. After that, if I will increase the force, I will keep increasing amount of force, then still length will be increasing. But after a certain point, body will reach in a certain region that after applying small amount of force, body will get more elongated. I mean that there will be no proportional limit and body will be under plastic region. I will just apply force, body will get elongated but will not return back. This will be in plastic region. Certainly, if I will keep on increasing the force, then there will be a point that material will break. And this will be known as breaking point. Now let's see all these points on this graph. Here, stress and strain. I am increasing the force, increasing the stress, and similarly the strain is also being increased. From O to A, we see a proportional region. We see a proportional limit and proportional result between stress and strain. This is known as proportional limit. O to A is known as proportional limit. After A to B, body will its length will increase, but the relation will not be linear. The relation will not be proportional. I mean that stress will not be proportional to strain. But from O to B, body will be in elastic region. Means it will have a probability to return back to its original shape. But after B, if I will increase force, then body will get elongated but will not return back. I mean from B to C, body will be in plastic region. It will not return back to its shape. After C, if I keep on increasing the stress, the force, body will reach certainly to a point. From where it will get broken. And D will be known as fracture point. Okay. So we saw this graph, how this experiment is performed, and different point on this graph. Now, based on this experiment and this graph, here we have a law, and this law is given by Hooke, known as Hooke's law. This law have a certain limit, then this is valid for small deformation. Hooke stated that when we increase stress, then it will be proportional to strain. He directly says that stress is directly proportional to strain. Now, when I'm taking both on one side, then stress upon strain, we will get a constant. And this constant is known as, constant K is known as moduli of elasticity. So, with this constant, we have three more terms. Like for the same constant, one more scientist known as Young, he have derived an expression known as Young modulus. Young used the same concept. He applied the same concept along the length. He calculated stress and strain, and he got the similar result that stress is proportional to strain, and the constant which was coming, he gave its name gamma or Y, and stated that this will be Young modulus. And from here we can see that stress and gamma, Young modulus is equals to stress upon strain. Here stress is restoring force. Upon area, and strain is changing length to its original length. Now this concept is very important for numericals. Most of the time numerical are being asked from the same concept. I will take a numerical problem on the same concept. Suppose there is a string being tied from the roof. This is roof and a string being tied from the roof, and on the bottom there is a block. And let's assume its mass to be 2 kg. Its length of string is 5 meter. And when this block is being hanged from this, then this body get a elongation of 10 centimeters. I am taking a random data. So original length was 5, and when this block was hanged, then this body got elongated by 10 centimeter. Now question is being asked, then calculate its Young modulus for this string. So we have result that Young modulus is stress to strain. Now for stress we have force, restoring force to the area upon change in length to its original length. Now here one term is missing. We need to know area of cross section. For what? For the string. We need one more data for the area of cross section. Let's suppose that area of cross section for this string will be 20 mm square, which is quite closer to practical result. Area of this cross sectional area of this string equals to 20 mm square. Now with these result I am going to calculate Young modulus for this string. Let's put these values. Stress, we have force here 2 kg block, then it will apply a force of 2g. Its weight will be 2g, which equals to 2, and I'm taking value of g equals to 10 upon area. We will take area of cross section equals to 20, and with unit here it's mm square. Then we will take it as, for 1 mm it's 10 power minus 3, and for mm square we will get it 10 power minus 6. Now change in length to its original length. Change in length is 10, but in centimeters, so we will convert it into meter, and original length is 5. It's already in meter, so we need not to convert it. Now just checking its calculation. 5 will go upward, and we will get a result. It's get point. So we will calculate its value. We will get value of Young modulus for this string. Now this is one of the simplest problem for this concept. Now question may be varied. Like here we are dealing with values of gamma, change in length, stress and strain. Question may be varied. Like question may be that Young modulus for this string may be given, and may be asked then what will be change in length, what will be increment in length. So we can also calculate, if this value is given, we have to calculate this one. And suppose also can give area can be asked, and force can be asked. Just we have to for the question we will have certain data, and certain data will be asked. So this is the concept from where we learn how to solve numericals on elasticity. Here we saw numerical on Young modulus. Similarly, we have another constant known as bulk modulus. This is defined for change in volume. Bulk modulus is defined for change in volume. This will be equals to stress upon volumetric strain. Volumetric stress upon volumetric strain. Here similarly we have to calculate the change in volume. So this is the short video. I explained what I explained about what is elasticity. It's two technical terms, stress and strain. We saw a graph between stress and strain, which is known as stress strain curve. We saw a law, which is Hooke's law, and after that we got Young modulus, constant of moduli, Young modulus, and we also saw a numerical on that. Similarly, numerical are also formed on bulk modulus. So this was a short video. I explained about this elasticity. Hopefully you like it. So thank you very much.